In this video, I'm going to be introducing the idea of the difference quotient and how it is related to our formula for average rate of change. So in a previous video, I introduced the idea of average rate of change. And we looked at a graph, and we took 2 points on the graph. And we said, well, let's let the first point be called A, and then this would be its function value, f of A. And then we said, let's take the second value and let it be equal to B, and then its function value would be f of B. And so our average rate of change was f of B minus f of A, the difference between the function values divided by B minus A. Well, what we want to do now is, instead of having a point B here, what I want to do is I want to say, all right, I don't know what B is, but I have this distance called H. And so instead of being called point B, we could say that this is A, which is this distance here, plus H, which is this distance here. And so the function value at A plus H, rather than being f of B, we would call it f of A plus H. So our formula for average rate of change would be slightly different. Instead of the f of B, we would have f of A plus H, the function value at the point A plus H, minus the function value at A. That part does not change. And instead of point B, we would have A plus H minus A. That also does not change. You'll notice that the A's down here will cancel out. And so what we're left with is the function value at A plus some value H minus f of A all over H. And this formula, which is just a slightly different version of the average rate of change formula, is a very, very important formula, and we give it a special name. And that name is the difference quotient. Okay? This is what we refer to as the difference quotient. And so the difference quotient is just another way of finding the average rate of change, but instead of knowing the second point, what we know is a very small distance between these 2 points. Usually the distance H is going to be something small, as 0.1 or 0.01 or 0.001 or 0.0001. These are all potential H values. Well, just like the average rate of change, the difference quotient is also a different formula for giving us the slope of the secant line between these 2 points. So if we draw a secant line, very good secant line there. If we draw that secant line, the difference quotient will give us the slope of the secant line, just like the average rate of change formula gives us the slope of the secant line. Slope of the secant line. All right, so let's do an example that kind of puts all of this together. Let's say that we have the function f of x equals x squared plus 1, and we have the interval 2, 2 plus some small increment h. And we want to let h be equal to 0.01. Well, that means that a plus h is going to be 2 plus 0.01, or 2.01, So our interval here is 2 to 2.01. See how this 2 plus h becomes the 2 plus the 0.01. Okay, so if we want to find the average of change between these 2 points using the difference quotient, let's write the formula down. F of a plus h minus f of a over h. Well, this means that the function value at a plus h is going to be the function value at 2.01 minus the function value at a would be f of 2. And then we are dividing it by h, which is 0.01. So the function value 2.01 is 2.01, and we are squaring it and adding 1 to it. I'm just evaluating this function now at 2.01. I'm going to put that in brackets. Minus, I'm going to evaluate this function at 2, so we have 2 squared plus 1, and all of that divided by 0.01. Well, you can go to Desmos and calculate what this value is, and it ends up being 5.0401 minus 5 divided by 0.01. And subtracting those two out, we get 0.0401 over 0.01, which ends up being equal to 4.01. So what is the 4.01? It is the average rate of change over this interval from 2 to 2.01, and it is the slope of the secant line over this same interval. Now, the nice thing about the difference quotient is what happens now if we just want to change h. Instead of h being equal to 0.01, let's let h be something even smaller. So if we let h be equal to 0.01, that means 0.001, then a plus h would be 2.001, and our interval is now from 2 to 2.001. Well, going through the same process, we're going to have 2.001 squared plus 1 minus, and this part is not going to change. It's still going to be 2 squared plus 1, which will be 5. But now we're dividing it by 0.001. Again, you can go to Desmos to figure out what 2.001 squared plus 1 is, but it ends up being 5.004001. Now you're going to want to keep this out to as many decimal places as possible, and you'll see why. Divided by 0.001, that gives us 0.004001 divided by 0.001. And when we divide that out, we end up with 4.001. And so this is our average rate of change over the interval from 2 to 2.001. All right, that is the difference quotient.